In August 1972, just months before the Apollo 17 mission landed on the moon, the deadliest natural disaster in space of our lifetimes occurred. The sun's magnetic field, which is in a constant state of motion, suddenly snapped into place and released the largest solar storm of our space age, sending a massive wave of highly energized plasma throughout our galaxy, which we call a solar flare. However, this was only the beginning. It wasn't just one solar flare that was emitted. In fact, it was a chain of an astounding 63 solar flares that were sent out directly near Earth, including 4 of the devastating and catastrophic Category X solar flares. If any astronauts had been in space at the time, they would have died in just a few minutes from the radiation poisoning that would have resulted from these huge energy particles. And this event brought even more radiation for a short period of time than the very core of Chernobyl's disaster. Meanwhile, millions of miles away on Earth, a deposit of 4,000 of the US Navy's magnetic sea mines off of the coast of North Vietnam completely exploded, compromising the USA's entire operation in the region. These massive solar flares also disabled phone and radio communications on a level never seen before throughout North America, as the solar flares caused an extremely powerful electromagnetic storm in the Earth's atmosphere. Fortunately, these solar flares aren't that common, right? Well, actually, they're happening multiple times every single day, and thousands every single year. It's just that most of them aren't quite as powerful to cause any problems. You see, scientists classify solar flares into 3 main categories. We have the C-class flares, which are the ones happening multiple times a day, with little to no impact on Earth but can still be detected by satellites and space instruments. Then we have the stronger M-class flares. These can be moderately powerful and occasionally cause temporary radio outages in certain regions that it hits, and these can occur dozens of times every single month. Then we have the big monsters, the deadly Category X solar flares. Even just a single one of these can have significant impacts on Earth's electromagnetic fields, and could wipe out any astronauts that happen to be in space at the time. And during periods of heightened solar activity, which we are in right now, these deadly Class X flares can happen as often as 5 or even 10 times per year. And there's been multiple deadly ones since this incident in 1972, including a Class X flare as recent as 2023, leading scientists to predict that 2024 and onwards is going to be a maximum period for solar flares. And the first man who ever set foot on the moon, Neil Armstrong himself, famously said that the thing that he feared the most about the Apollo 11 mission and landing on the moon was the potential for a solar flare during the journey. And many astronauts and scientists have all expressed similar concerns of the dangers of solar flares in regards to space travel. And these solar flares are largely mentioned as one of the biggest reasons why we've never returned to the moon in the last 50 years, although NASA is finally trying to change that now with their new Artemis missions. You see, our sun has an incredibly powerful magnetic field, always twisting and turning in extremely complex patterns due to the constant releases of massive energy. And this results in the sun's magnetic field getting all entangled within itself. And as the magnetic field twists and distorts and goes all over the place, they eventually snap together with aggressive force. And due to the sheer speed at which this happens, this sudden reconnection causes a violent release of energy in the magnetic field, giving birth to solar flares. And this is maybe similar to how the movement of Earth's plates might cause a tsunami. Consider a solar flare as the result of a tsunami on the sun, only with deadly invisible radio waves that can end your life in 5 minutes. Fortunately for us though, our beautiful planet Earth has a lovely and amazing atmosphere. And this is what protects us all from the sun's harmful rays and from these solar flares. But the same cannot be said for someone in space beyond our atmosphere. The Apollo 17 mission was scheduled for just a few months after the occurrence of this massive solar flare, and things fortunately calmed down and then the mission continued successfully. But this whole event shed a completely different light on space travel. While the Earth's atmosphere protects things in orbit such as the International Space Station, or any of you aspiring space tourists who might want to see things for yourself, the fact of the matter is, once you leave the atmosphere, the sun can just do a Thanos snap and end your existence with little to no warning. And current technology only allows us to predict these solar flares maybe 7 or 10 days in advance reliably. and anything beyond that reaches the territory of complete wild guesses as we try to predict them further and further out. When NASA deployed the Perseverance rover in 2020, the travel period lasted nearly 7 months for the rover to go from Earth and land on the surface of Mars. And Mars doesn't have the same global magnetic field as Earth does, and it has a much thinner atmosphere, meaning that it doesn't shield the surface from radiation nearly as well. Not to mention the time it would mean for a return trip as well too. So for a human trip to Mars, there's potentially as much as 2 years of pure random chance for the sun to obliterate you. And while most deadly Category X flares might just give you a small little dose of discount cancer, it's just impossible to predict, and there's a very real chance of just getting wiped out. And what's even worse is that since we can predict these solar flares in the short term, if you go on a trip to Mars with our current technology, it's entirely possible you would end up in a situation where 4 months into the trip, and you can see that there's a crazy solar flare that's going to hit in the next few days, and there's absolutely nothing you can do about it. And you'll just be trapped in the void. However, there is one saving grace for all this that can allow the journey to Mars to still be possible. You see, the sun follows an 11-year cycle of increased and then decreased solar activity. And during this solar cycle, the sun's pattern of rotation and energy causes the magnetic field to become more and more complex, until it eventually just becomes so tangled that the north and south poles completely flip on each other. And eventually, over time, it stabilizes and remains calm for an extended period. We currently started a solar maximum period in 2023, and the top of this cycle is expected to occur this year and in 2025. During a solar maximum period, we can sort of predict heightened solar activity a few months in advance, but not the actual solar flares themselves or the intensity. We can just tell that, oh, it's gonna be really bad or it's gonna be not so bad. And this is a huge part of why NASA and SpaceX are really pushing for their mission to Mars to launch by 2028. They are aiming to do the trip during a minimum period of solar activity, and they'll only have a limited time to complete the launch and do the full journey before the solar flares rapidly intensify and they have to wait another 5 or 6 years to try again. And this is all because with our current space shuttle technology, we can only really prevent about 20% of the radiation from a massive solar flare, meaning that if you're flying in space and a mega solar flare hits, well, you might not die in 5 minutes, but you're certainly going to get cancer and you'll probably be gone in just a few months. But during the minimum periods of activity, this can definitely be enough protection to complete the journey to Mars and return with a strong enough chance of survival, and the potential for a solar flare disaster is just the first part of many of the real horrors and dangers of going to space that causes many, if not most, astronauts to hate going to space and to regret their journeys in many cases. In 1986, as the whole country was watching, the Challenger space shuttle famously exploded during the launch, unfortunately putting to rest all of its crew members. And along the way since, our space missions have failed at a rate of around 6 to 8%. While not every failed mission is nearly as deadly as the Challenger, the fact remains that going on a space mission outside of the Earth's atmosphere gives you a real chance to never return of around 3 to 5%. And that's only from the human errors in our engineering. And accounting for solar flares and other dangers, the chance of dying from a trip to space if you go outside of the atmosphere is easily higher than that. And this means that being an astronaut in the United States is actually the second most deadly job in the entire country, second only to being the president, which has historically had a chance of successful assassination of around 9%. But I have to say that the chance of you subscribing after you watch this video is way higher. In fact, our scientists predict it could almost be as high as 100%. So hit that subscribe button right now so our scientists can retain their jobs and you can do your part for our data collection of the universe. Now, on top of all this, the effects of going to space on your body are immense. We are not evolved as humans to survive long periods of time with little to no gravity. And so being in space, especially for extended periods, almost always results in permanent, if not massive, losses of health even after you've returned and recovered. You see, when you travel into space, the microgravity has all sorts of effects on your system and the function of the human body. The most common effect that you've probably heard of is a result of massive bone and muscle loss. Astronauts commonly lose 1 to 2% of their bone mass per month while in space, and extended trips can often result in permanent loss that cannot be recovered.
You've got little receptors in your bone that if you're moving, those receptors say, cool, let's make osteoblasts which make bone, and osteoclasts which eat bone, and have them constantly remodeling bone. The problem is when you're floating, if you're not using your extremities, your body goes, I don't need them, get rid of them.
But what may have flown under the radar that I find even more terrifying is how going to space affects your eyes. As you enter microgravity, the fluid in your body shifts around and moves in ways that it's not really supposed to. And these fluid shifts within your body can increase the pressure on your brain and damage the optic nerve that's responsible for your eyesight. This leads to problems of flattening of the eyeballs, swelling of the optic nerve, and potentially irreparable damage to your vision. And it's reported that over 60% of astronauts that go to space, even for a short period of time, experience some degree of vision damage upon returning to Earth.
Cause to this and come up with a countermeasure to prevent it. And perhaps those countermeasures will be just as effective to people suffering from this malady on Earth.
And while many of the astronauts recover, the cases are much worse for those that stay for extended periods, often resulting in permanent damage in the eyes. And while with some very tactical planning and smart engineering, you might be fortunate enough to avoid a solar flare that ends you instantly, the solar activity still has massive effects for trips outside of the atmosphere, and the radiation can undoubtedly affect you in many ways. And even at lower levels, the radiation will massively increase the chance of getting cancer and can also cause damage to the brain. Many famous astronauts such as Alan Shepard and Sally Ride famously had their lives cut short from cancer. And perhaps even more famous, one astronaut, Lisa Caputo, had an intense psychological episode and assaulted a taxi driver after coming home from space. Now, of course, we can't say for sure that going to space was the cause of this, but it's not uncommon at all for astronauts to have signs of minor or even major brain damage upon returning home. And while most of the time this damage can heal itself, it often means years of recovery or never fully returning to your true self again. And so going on extended trips to space, especially if you leave the atmosphere, often means shortening your life by as much as 5 to 10 years on average. And it's almost guaranteed to cause major health problems upon return in the short term. And that's if you're fortunate enough to not get cancer and not go blind or get brain damage or be obliterated by the sun. And this isn't even the worst thing of them all. You see, there's an even worse phenomenon that happens when you go to space for the first time, to the point of causing psychosis or just completely shattering your mental self. Because to go to space is to truly experience the reality of life in the universe, and to be confronted face to face with how fragile our entire existence really is. Astronauts famously report that being in space, especially when they eventually need to go outside and perform some activities outside of the spacecraft, it's unbelievably terrifying and disorienting. And many astronauts reported saying that it was to the point of shattering their brain, due to the existential terror and being confronted with the reality of total, unending nothingness. And how that we can't do anything to save ourselves from whatever is going to one day come from that void and wipe us out from existence. As whether it's going to be a billion years into the future, a million years, or perhaps even in our lifetime, it's pretty much a mathematical inevitability that our planet Earth will one day eventually cease to exist. And there's further evidence to support this. In Mary Roach's publication on Mars, she shares some incredible stories and anecdotes from a collective groups of astronauts who all went to space. Many, if not all the astronauts, experienced an overwhelming sense of terror and dread when they saw outer space from a shuttle window for the first time. And when they went out of the shuttles for their maintenance routines, it was reported as being absolutely terrifying and disorienting, to the point of being almost completely brain destroying. And to even just stare out into space from the window of your shuttle is often a complete and overwhelming sense of dread, to the point where it often causes massive panic and completely ruins any enjoyment of the trip for many astronauts as well as space tourists. Very famously, William Shatner wanted to go to space for decades, and then he experienced this phenomenon and had massive panic and completely ruined the trip and his mental perspective.
And there's another, even more important fact that moved me to tears, is when I saw the bright blue covering of Earth that's only 50 miles wide, and we plunged through it at 2,500 miles an hour, broke through it, and then all of a sudden, like a punch in the face, there was the blackness of space, and none of the mystery of the twinkling stars, the galaxies, just pure blackness.
And even if it might seem amazing, no matter how badly you want to go to space, regardless of how much time and effort you put into preparing to become an astronaut or saving up money for space tourism, even if going to space is your greatest, biggest goal in life, you might still feel some intense fear once you leave Earth and find that your time in orbit wasn't what you hoped it would be. And almost ironically, this phenomenon is actually one of the leading conspiracies driving the force behind people not believing the moon landing was real. Because when the Apollo 11 astronauts returned home, they held a press conference, and we can see some of the moments here that share the mood. The astronauts here, they're almost serious and intense, almost depressed, while everybody expected them to just be super excited and happy. Going to space is just often really depressing for many astronauts. I mean, consider this for a second. Humans, we get sad from the simplest things, whether it's a rainy day or some bad weather, or maybe you just stubbed your toe or tripped over a curb. Now, can you imagine those sort of sensitive feelings and replace that environment with being trapped in a space capsule for days or months or even years, surrounded by just eternal death and void and absolutely nothingness? Now, with all that said, if you still really want to go to space yourself, I'm rooting for you because, well, someone's got to do it, but how bad would it really be in a more realistic estimate? Well, first off, if you go to space as a space tourist, it's going to be way safer than anything that I've mentioned in this video. Because space tourist flights, at least as far as I'm aware, they don't actually leave the Earth's atmosphere. And if you stay within the atmosphere, the danger of a solar flare is essentially zero. And if you go on a small trip for a day or two, the health dangers of the microgravity environment do become fairly minimal, since the effects are only very significant when exposed to them for an extended period of time. And so if you want to go to space yourself, the most danger is just the phenomenon of overwhelming dread and confronting the true reality of life in our universe, and staring face to face at the fact that we are fragile, alone, and there's nothing else out there. And while this phenomenon doesn't happen to everybody that goes to space, just understand that if you do want to go to space one day, it might not be what you expect. And this is why many astronauts hate going to space and regretted their journeys in some cases. This has been Jeremy B with Space Lore. If you want to see another space documentary, YouTube believes that you'll enjoy this one a lot. It's going to cover a ton of really cool things, and this is YouTube's best prediction of the video from our channel that you'll enjoy the most. This has been Jeremy B, signing off.